I'd like to introduce our speaker tonight. He's Professor Jake Boswell from Ohio State University in the architecture department. And he's going to describe a little-known, very obscure project that was at the very beginning of the cutting edge of renewable energy in the 1970s that occurred right here in Miamisburg and involved people at the Mound Laboratory. And so almost no one remembers it, almost no one knew of it, but it is happening. Jake decided to research on it for some reason known only to him, but at least now we have an opportunity to document this really unique project of renewable energy from over 50, or almost 50 years ago. Without further ado, welcome Jake.
Thanks. It's really great to be here. And can you all hear me okay?
Yep.
Okay. I have a tendency to be a little soft-spoken, so if you ever can't hear me, just like flag me down. As Rob said, I'm Jake Boswell. I'm an associate professor of landscape architecture at the Knowlton School of Architecture at Ohio State. And I'm going to talk to you about a project that I just recently published an article on called the Miamisburg Solar Pond. Before I do that, I just want to thank a couple of people here, particularly at the Mound Center. Rob for inviting me, of course, but also for helping me track down quite a bit of the information, particularly the later documentation on the solar pond. Jackie Miller for helping me find a lot of the photographs that existed and that were taken early in the solar pond's life. Jack Melke, who dug through Dr. Leighton Wittenberg's reports and other writings on solar ponds and kindly sent them to me during the pandemic, no less, which gave me a lot of time to read them. Gary Giles, who is at the city of Miamisburg, who went through the city's archives with me, and Gary Pettigrew, who is a member of the Miamisburg Historical Society, for going through their archives and sharing that information with me. This was an interesting project to research, and I'll go a little bit into my esoteric reasons for wanting to study this and sort of background of my own interest into this project. I'm going to start with a caveat on the presentation, which is this project really ends in a mystery for me. I have yet to be able to track down when the solar pond went offline, right? So I know that it was at some point in the 80s, but if anyone here knows that, I would love to hear that story because it's been a big mystery to me all through this project. So I'm going to start with a little bit of disambiguation here because Miamisburg has a lot of really interesting history around pools. I'm primarily going to be talking about not this pool, and I'm going to use pool and pond, right? Pool, swimming pool, pond, solar pond, okay? And you'll see why that's important as a distinction in a moment. Miamisburg's first pond was here at center of town. So this is the Sanborn Fire Insurance map from Miamisburg showing Central Avenue and First is over here. And the very first pool, public pool in Miamisburg was located right in the center of town, right there. It was built in 1913, close to the current municipal courthouse. And this pool, if I can advance the slide, was it really kind of a product of its era. It was decommissioned in 1934 because it was unsanitary. This pool was probably fed directly from the river. Water was pumped directly from the river and then out again. This pool kind of what is Miamisburg's early kind of history of pool, or represents Miamisburg's early history with pools, and I think is indicative of a kind of interest in the city in its pool projects, right? So this pool is relatively early in the history of municipal pools in the United States. The pool I'm going to talk about is really kind of interesting in its interest in technology. And then, of course, your newest pool is also pretty cutting edge, pretty early in terms of its kind of historical era of development. So this is an interesting pool, but I'm not going to be talking about this pool. Keep clicking on this thing. The pool I'm talking about was actually here. So this is, of course, what is today known as Community Park in Miamisburg, just over to the west of the Mound Center here. There's the river, just to orient you. And this is the park as it exists today. But in 1934, with help from the Works Progress Administration, the city of Miamisburg built a new pool, a pool project to replace its first pool. So this pool consisted of an Olympic-sized swimming pool, a wading pool, and a bathhouse. Some of you may know that Rob remembers this bathhouse. It had a second floor dance hall associated with it. It's kind of a really good example of a Works Progress Administration pool built during that era. Like many Works Progress Administration pools, it was unheated and unfiltered, right? So this pool, I have some pictures of it under development here. So pictures from the WPA archive showing the pool under construction. This pool would be filled, it was chlorinated, but it would be filled, unheated. The water would heat up over the course of, say, a week, and then the water would turn slightly green, and then it would be evacuated again, right? And then it would be really cold again for a little while, and the cycle would start again. There's a really nice series of articles that were written about this pool in the Tavern Log by Diane Warwick in 2011, kind of as a remembrance of this pool, mostly from its early kind of heydays. I'm going to be talking about this pool later, kind of toward the end of its life. I think one thing that really struck me about this pool is that this was partially funded by Works Progress Administration funds, but of course the city of Miamisburg needed to kick in a certain amount of money in order to sort of push to make the project a reality. Diane Warwick calls this one of the heaviest primary votes ever counted in Miamisburg. There were 1,700 votes cast. This was a contentious issue. We'll see another contentious political issue associated with this pool later. 1,700 votes cast, and apparently it was so contentious that the children of Miamisburg sort of poured into the streets before the vote in order to protest on behalf of the creation of this pool, right? Because they'd been without a pool for 2 years at that point. Just another photograph of the pool under construction, and here's a postcard of what it would have looked like after it opened in 1936. Photographs of the pool kind of during its heyday. So on the left, you can see the pool in the early 40s. These are, again, from that Tavern Log article, and the bathhouse there. And then another pool, a shot of the pool from the city's archives in the mid-60s. You can see the wading pool and the Olympic swimming pool. And this was quite common at the time. I'm a bit of a pool historian, to have a set of grandstands, both for watching pool events, but also just as kind of spectator watching. So a lot of WPA pools actually have that feature, which is quite strange in a pool today. The thing that I am really interested in about this pool is what happens to it in the mid-70s. So in the 1970s, in the mid-70s, they start to consider heating the pool, right? Miamisburg, the city of Miamisburg wants to heat the pool. They want to add a filtration system to the pool, and they need to resurface the pool. And so this is, of course, in the mid-70s, the middle of the oil crisis. And so they were really faced with a decision about a pretty hard decision about how they would do this, how they would go about it. And during that debate, the proposition is made to use what was a pre-existing lake, and to transform that lake, which we actually think was the old cooling pond from the power plant that was here, transformed that pond into what was known at the time as a solar pond. And this was kind of cutting-edge renewable energy technology that had kind of gone through its early research phases with a scientist at Ohio State, I'll talk about in a minute. But here was the first, Miamisburg was actually the first time that this technology was utilized in a real project, right, not an experiment, and sort of at a municipal scale. So this is where the solar pond was located in relation to the pool. The other part of this project is that they would build a new bathhouse, right, which is still the community center that's there. And they built a concession stand. And the interesting thing is that this pool, right, would essentially heat the bathhouse and the swimming pool and the waiting pool, right? So it was a pool to heat a pool, which is an interesting proposition. So just a little bit about how a solar pond works. So these are diagrams by Harry Zvi Tabor, who's an Israeli scientist. And he's considered the father of Israeli solar research. And he did much of the early work in the 1960s on solar ponds. So a solar pond is actually a naturally occurring phenomenon. The one at Miamisburg and all of the man-made ones are kind of an amplified version of that naturally occurring phenomenon. So when you get a highly saline body of water, what can happen is that in a normal body of water, you of course get convection, where cold water sinks to the bottom and the hot water rises to the top, and you get a cycling in that body of water, and so it stays. The bottom is always slightly cooler than the top, but it stays relatively consistent temperature. In a solar pond, whether it's naturally occurring or man-made, that convection cycle stops. And it stops because the hypersaline water sinks to the bottom and stays at the bottom, right? So it wants to stay there. It's heavier than the water, the fresh water that gets suspended on top of it. But of course, sunlight is still penetrating that water and continuing to heat up that hot brine that's now stuck at the bottom. So you've got a layer of water at the bottom that's essentially insulated from above, and it continues to accumulate heat, right? It's basically a big solar battery, a naturally occurring solar battery. So the pond, right, solar ponds use this phenomenon basically to trap solar heat, store it over a long time, and deploy it. So beginning in the 60s, we see the earliest research on solar ponds. This is conducted in Israel by Tabor. This is an example of an early experimental pond that was built in Atlit, Israel. And what's interesting is that Tabor the Israelis are interested in using this technology for generating electricity. They don't need heat in Israel, not surprising. They don't need very much of it in Israel. The Israelis are interested in using this technology for electricity, but of course what you get out of it is really low-grade heat, right? So the hot brine at the bottom really never exceeds about 180 degrees, 190 degrees Fahrenheit, which is really not a temperature that one can generate electricity from very efficiently. In one of his papers in the 60s, he suggests that actually it would probably be better to use this technology in a northern climate and to actually just use it for heat, right? To use it for heating buildings rather than generating electricity. And that's, as this technology moves to the United States, that's exactly what happens. So the very first, and I think the way that this gets on Miamisburg's radar and gets on Leighton Wittenberg's radar, and we'll talk about more in a minute, is through this project at Ohio State. So Carl Nielsen is a physicist professor at Ohio State. In the early 70s, he gets funding to build a series of solar ponds of kind of increasing complexity. He actually starts at Donscott Airfield building a solar pond in a kid's outdoor bathtub, or a swimming pool. He tests that over a summer. he draws some initial conclusions based on that, and then he gets funding to build this still quite small one. This is a 200 square foot solar pond that was also built at Don Scott. And Nielsen starts to write about the sort of impact of this and the effectiveness of it. He observes, he's the first person to observe a solar pond freeze over in winter and maintain its bottom temperature, which is an interesting phenomenon that happens at Miamisburg as well. This project was featured in the 1975 Farm Science Review, which was held at Don Scott. They held tours of it. It's kind of broadcast pretty widely across the Midwest as like something to come see, as like a new agricultural technology. In 1977, it makes the cover of, or it gets included in Popular Science, right, which is sort of mark of popular distinction. So you can see at solar ponds heat heat from a hole in the ground. So Popular Science runs this article on Carl Nielsen's experiments at Ohio State. They interestingly, as a part of this article, one of the things Nielsen was sort of famous for saying is that a 1,600 square foot house, he argued that a 1,600 square foot home in Columbus, Ohio could be heated, could meet all of its heating needs with a 1,600 square foot solar pond, right? So you could build a solar pond in your backyard and heat your home with it, was Nielsen's idea. There's a guy in German Village that actually built one of these in his backyard to heat his home. He managed to do that for a couple of years, sort of using a modified, what we would today we might think of as a modified geothermal system, which is sort of pumping that hot brine through the house. This gets picked up, and there are a couple of other solar ponds built throughout the state. So the second of these was actually built at OARDC, the Ohio Agricultural Research and Development Center in Wooster. They built a small solar pond that they used to heat a greenhouse. This was sort of a very romantic version of what that would look like. It actually, in the end, didn't look anything like that. This is it. It's sort of like a kind of raised pond. But kind of on the heels of all of this, Miamisburg began to kind of clearly pick up on this idea. Rick Bryant, who was the parks manager at the time for Miamisburg, had contacted Nielsen. Nielsen had come and sort of had a discussion with him at least about the use of the solar pond for heating Miamisburg's pool. So in 1976, Leighton Wittenberg, who was the director of the Mound Center's Energy Research Group, wrote a proposal with Rick Bryant, the director of public parks for Miamisburg, to the DOE, requesting funding to build a solar pond to heat, sort of experimental pond, but that would be used to heat the pool. That funding was denied, but they eventually got funding from the state's Board of Recreation to do the same thing. And this is the plan that they put together. Right? So they would demolish the existing bathhouse. This shows the new bathhouse. This is the concession stand, and most importantly, the solar pond going into place just south of it. Photograph of the pond under construction. This is in the fall of 1977, they tore down the historic bathhouse, they dug the pool, and then in 1978, they opened the thing. And it took a year for the pond to come up to temperature, to reach full temperature. And then in 1979, they started to actually use it to heat the municipal pool. So picture of it under construction. A couple of things that get embedded into the construction of the Miamisburg solar pond is something that Nielsen didn't actually include in any of his own work, but which made it into this build out of it, which is the 45-degree edge, right? So as Nielsen thought that this would lend a more stable pond edge, but also increase insulation into the pond water beneath. All of his have been built to that date with 90-degree edges, and actually all of the Israeli pools were built with 90-degree edges, which is a kind of strange decision when you think about it. But this is kind of one of the things that I think Carl Nielsen really adds to this project. It was built initially with a series of, with a copper heat exchanger. So the heat exchanger was actually lowered into the hot brine at the bottom of the pool. A working fluid was passed through it, and then that was brought into this was situated in a pond, and the hot brine was circulated through the pool in order to bring it up to temperature and the bathhouse. This eventually runs into problems, right? There's a lot of corrosion that happens in a hypersaline environment that they didn't necessarily account for, and eventually this is kind of pulled out, and they do an above ground one in the early 80s. Just a picture from the Daily News, that going in. This is what the pool looked like, pond looked like initially. Sorry, I'm breaking my own rules. This is actually Leighton Wittenberg overseeing the initial filling of the solar pond in 1978. It's early spring of 1978. And this is it just before the opening of the pool in the late spring of 1978. So you can see that the pond is constructed and almost full, but it wouldn't have come to temperature by this point. And then the pond, the pool is mostly completed. So what's interesting about this is that Wittenberg, it gets a lot of attention kind of right away. And for a project that is nearly forgotten today, it really kind of changed the conversation around solar energy in the country pretty rapidly and for a short but fairly sustained period of time. So Wittenberg makes the cover of, Solar Engineering magazine in 1980, and they published this, under the title "Solar Pond in Ohio Proves proves economic viability." So by 1980, they had run this for almost a year and a half, and they believed that they had sort of proven that this could effectively work. This technology could effectively work in a cost-effective manner for heating. I'll give you some of the data on this in just a moment. Here's Leighton Wittenberg and his kind of main associate, who was publishing along with him this time, Mark Harris. So we see them publishing on a lot, but we also see the sort of extension of the idea of the solar pond in 1979, 1980, and 1981, sort of all the way into the early 80s as a kind of scientific imaginary that really kind of resonated across a pretty wide region. So this is a bit about the farm at Worcester, right? It's a big publication on the farm at Worcester, calling it the future of farming, where farmers would utilize solar ponds as a way of heating, keeping livestock warm, and also drying grain and things like that, heating greenhouses. It makes it into newspapers across the country. So this is the Sunday Journal from Lincoln, Nebraska, talking about the ability for solar ponds to be used as heating in colder climates. Right? This is the Des Moines Register. This is the Sacramento Bee. The Sacramento Bee ran this whole section of the newspaper, a special issue of the newspaper, on kind of new technologies in sort of architectural form, and I actually think that the one for solar pond is really funny, and it was putting the solar pond on the roof of the building to heat it from above. The city of Northampton, Massachusetts actually puts together an entire 370-page DOE proposal for heating the city of Northampton using a series of solar ponds that were to be located in its park system, right? So you would, the idea was that they would build a series of really giant solar ponds and use those as a kind of renewable heat source for the city. They theorized that they could supply 85% of Northampton's heating needs with solar ponds. This is 1979, right? So right on, and they cite the project here in Miamisburg. California gets a huge grant from the DOE, $1 million grant to study the possibility of converting Salton Sea into a giant solar pond for energy generation. This is, of course, if you're familiar with the Salton Sea is a big sink. It's actually the most rapidly increasing salt body of water in the world, just because it receives a lot of agricultural runoff. They did this major study speculating on the capacity of that to work for energy generation. There was another one proposed for the Great Salt Lake as well. The one for the Great Salt Lake was never funded. And this is just some of the energy data that Wittenberg published relative to the Miamisburg pond. I should say, at the time of its construction, Miamisburg pond was the largest solar pond ever constructed in the world. It was that for quite a long time. It was surpassed in the mid-'80s by an Israeli project that was actually suspended in the Dead Sea. But here you can see kind of heat curve for the pond. We were talking earlier about how the winter of 1978 was incredibly cold in Miamisburg. Negative 20 degrees, he said. And the pond actually iced over. They're quite proud of the fact that the pond iced over. You can see this is Celsius, this is Fahrenheit, months down here, right? So it's, I'll do it in Celsius because I can read it a little easier, but 50 degrees Celsius at its height, right? So right as the pond is coming up to temperature in 1978, of course it drops during the winter, but it never goes below 30 degrees Celsius, about a little bit more than 80 degrees Fahrenheit during the winter that it froze over. So there we have, I'll show you pictures of it frozen over here in a minute. So it stays around 80 degrees Fahrenheit throughout the winter, which is quite good. This is, of course, the first summer that they used it. You can actually see in the data the moments when they're really beginning to draw energy off of the thing. But it reaches a kind of maximum of about 150 degrees Fahrenheit during 1979. It actually gets hotter than that in 1980, but I don't have a graph of that on the These are graphs showing the kind of salinity gradient across the pond. So depth happens this way, of course the salinity gradient goes this way. So you can see what this is just showing is the water on the top of the pond is actually not very saline at all. The water at the bottom of the pond is incredibly saline. Pictures of it frozen over in that winter, midwinter 1979. This was like January, February 1979. In 1982, in 1980, Wittenberg proposes to the DOE, he writes a grant proposal to the DOE to replace the corroding heat exchanger at the bottom of the pond, and they replace it with this above-ground system. So this is a photograph from 1982 showing that above-ground system, and then a paper published around that same time talking about the corrosive nature and the salt brine and this new system that they put in place for, in this case, they would pump the brine out and put it through an heat exchanger above ground so that they could maintain it more easily, and then put it back in the pond. So just a quick timeline of this, right? So in 1977, the old bathhouse goes through demolition, excavation, and resurfacing. During the spring and summer of 1978, construction finishes and the pond is brought up to operating temperature. They use it for the first time in summer of 1979, right? So from July to September of 1979, it's put through use. During that time, Wittenberg calculated that they drew about 40,000 kilowatt hours or 136 million BTUs from the pond over that summer, so not an insignificant amount of heat. But Wittenberg used that data to estimate that the pond's real capacity was about 1 billion BTU once it came up to full temperature and full stability. And it actually achieves almost that in the next year. So in 1980, they estimated that its full energy use was about 96 million BTU, or 960 million BTU, sorry. But they also start to note this corrosion. And I think this is where I get into the kind of mystery of what happened to the solar pond. In 1980, Wittenberg writes to the DOE for assistance with that new heat exchanger. We know that they got that assistance. We know that they built the new heat exchanger. It was installed in 1981. Wittenberg publishes the final report on the pond in November of 1982. That summer, 300 million BTU were withdrawn from the solar pond just to bring the pool up to operating temperature in May. And they talk about the performance of the new heat exchanger quite positively, right? There's no indication that that second heat exchanger was having problems at that point. I think the critical date here is that Wittenberg retires in 1982. So once Wittenberg retires, the project kind of drops off the radar of obviously of his publishing, but also of the Mound Center's publishing. So it sort of becomes a mystery from that point on. We get references to the Mound in the local newspaper, the last of which centers around the erection of the water slide, right? This is the second political controversy surrounding the Miamisburg pool. They built this water slide in 1984. In order to do it, they raised the price of entry to the pool from 50 cents to $1.50. So they tripled the cost of going to the pool because of to pay for the construction of the water slide. This was a huge issue. Councilmen actually had to walk out to avoid having to vote on this water slide. Eventually it passes, but there's a lot of accusations around like cronyism coming out of the creation of the water slide. The next year, a lot of the council members actually get voted out in 1985 because the pool had run a major deficit the year before because of the construction of the water slide. The pond, right, the largest solar pond in the world, the thing that's heating the pool, is sort of mentioned as the thing that the slide is sitting beside, right? Like it's not, so I know that it's there, but it's clearly not a major thing anymore. And then I sort of lose track of it. Of course, it gets kind of subsumed by other things. So that article about the slide is the kind of last mention of it I find in print. And then in 1986, we start to get the sort of what are the beginnings of the sort of end of the Mound as an operational lab. So the EPA begins testing the Miamisburg drinking water for tritium and thorium. In 1989, they do a second audit of the Mound facility, sort of in order to test its environmental standing. There's an accidental release of tritium gas in 1989, and then the EPA cleanup begins in 1994. So in 1994, they begin to convert, of course, the Mound from defense to commercial work, and cleanup begins on the Mound. the EPA eventually gives the city of Miamisburg $4.6 million to fund the new Sycamore Trails pool, which is still the pool, the main municipal pool for the city of Miamisburg. 1995 is the last summer that the pool, right, the old WPA 1934 pool was in use as a pool. I get no indication from any of the articles talking about its closure or the construction of the new pond, or the new pool, that the Miamisburg pond, the solar pond, was still in operation at that time. So I know that the pond existed as a thing into the late 80s, but I don't think it was actually producing heat at that point anymore. It appears for the sort of last time in a 1994, or sorry, it's gone in a 1994 aerial, and I found it in a 1988 aerial. So somewhere between there, between 1988 and 1994, it disappears. In 1996, the EPA takes over municipal park and uses it as a kind of staging ground for the environmental cleanup of the Mound plant. And then in 1997, the pool opens. So this is that picture from 1994. I like to look at this because you can see how far aerial photography has come since 1994. But you see the pool, there's a pool close to at the end of its life, the bathhouse, which is still there, but of course this is the site of the solar pond, and it's filled. So Rob, at the beginning of this talk, kind of alluded to the mystery of my interest in this project. And I've been interested in this project for a long time. So I'm going to talk a little bit about why, and maybe point to some of what I think is the potential of Miamisburg and lessons that we can learn from Miamisburg going forward, from Miamisburg solar pond going forward. So this is a kind of very hypothetical project that I did very early in my career. I began work on this project. This is a shortlisted competition entry for a brownfield site in Copenhagen. I was a finalist for this project. I got beat by the point of this project was to showcase emerging renewable energy in a kind of civic setting, right? So I proposed this really massive solar pond. I had been familiar with solar pond technology in the Israeli context. And in researching the work for this project, I came across Carl Nielsen's work, and then also the Miamisburg existence of the Miamisburg pond. And it struck me as really interesting because this project sort of uses, in this case, a solar pond within a big greenhouse to heat a bathhouse in Copenhagen and a kind of harbor bath. It's connected to a harbor bath. So this project really isn't important other than the fact that it happens relatively early in my career, and it really solidifies an interest of mine in the production of energy, right? Production of energy and energy infrastructure as a kind of municipal act, right? So typically when we think of energy generation, we think of it as a kind of far-flung thing, right? It happens very far away, it happens in nuclear plants and coal plants that are sort of in the hinterland. And we don't think about it in our cities as an active part of our lives, other than when it breaks, right? And then we don't have it anymore. This project, I'm still bitter about. I got second place in this competition, and I got beat by a giant duck that was covered in solar panels, half of which face north, right? Which is sort of tells you a lot about the state of kind of tells you more about the state of sort of architecture competitions than it does about anything else. The interesting thing about this project, and you can kind of see me noting it here, is that this project was really about production, right? So the question was, make something that generates electricity. And in researching this and in talking with the mechanical engineer that I was working with on this project, we really came to the conclusion that it would be better served as a kind of battery, right? So it's good at, a solar pond is good at storing energy. You get a relatively low kind of constant energy production, but you could use it as a kind of peaking plant. So you could draw down that energy relatively quickly at times when you critically need it. And I think this is kind of that idea of the solar pond. You know, do I think solar ponds are the answer to energy transition globally? Absolutely not, right? Like the energy transition is not going to happen relative to solar pond. But I do think we see a kind of interesting phenomenon happening, and I think it was really crucially pointed to this summer. So the map on the wall is showing you all of the new batteries that are being built in Texas. So if you've been paying attention, how many of you are engineers? Okay. So I will explain this to some extent, and I apologize to the engineers in the audience if my explanation is a little bit dumb. I'm not an engineer. But Texas has been building solar plants and wind plants exponentially, right, the last decade. Texas actually has majority of sort of producing the most energy from solar and wind in the nation. The orange dot, or the green dots are batteries that existed prior to the summer of 2023. And so this summer, Texas has really relied on these batteries as a sort of balance to their wind and solar production. To tell you how successful that is, the orange is all of the battery projects that are proposed, right? So this is really about energy storage. And the game in Texas now is not how much renewable energy we can produce, but how well we can store that energy, right, to use when we need it. You can actually see, this is their energy production graph of their energy production over the course of the day, right? So 1 in the morning, midnight. And you can see the orange here is solar energy production. It makes up a huge proportion of their energy grid, but it actually happens at a point when they don't need it all, right? This is the central problem with renewable energy, is that oftentimes we're generating it, it's super efficient, but when we're generating it is not when we actually need it, right? We actually need it slightly later in the day when everyone gets home from work and turns on their air conditioner. And you can actually see that show up in the graph. This brown is the batteries kicking in to make up that drop, to make up the difference in that drop off in solar energy production. The majority of the storage in the United States today, right, is pumped hydro. These are these sort of big lakes, remote lakes, where they'll pump water during low energy usage, and then they'll release it during at times when they need it. The majority of the batteries that are being built in Texas, the majority of those orange dots are electrochemical batteries. Electrochemical batteries have a lot of problems. From my perspective, one of their main problems is that they look like this, right? Big fields of trailers that occasionally catch fire. So this is a sort of rather unsatisfactory answer to energy production, right?
So you say they're not as pretty as pond?
They're not as pretty as plants. And yes, that's what I care about as a designer. I'll see it through a lot of this. But I think that Miamisburg is interesting because what we know, and what we know kind of coming out of the use of batteries in Texas this summer, and kind of theorizing about energy storage from slightly before that, is that we know that these things are more effective if we use them in what are called microgrids. So we know that locating the batteries closer to where they are consumed and sort of being able to more nimbly pinpoint the way in which, or the times in which energy is used, is better done at sort of a local scale than it is at kind of whole grid scale. What that means for energy storage is that it's better located in population centers than away from population centers, right? Which is a fundamentally different geographic way of thinking about energy than we have done for the last 100 years. And probably means that as we move into an era where we're seeing increasing renewable energy generation, decreasing fossil fuel energy generation, that we'll see batteries become a kind of everyday part of our municipal landscapes, right? And that's where I think Miamisburg is really interesting because it essentially is a large battery. It's a power plant that existed as a fundamental part for almost a decade, as a fundamental part of a recreational landscape, right? So not a very typical way we see energy happening, energy production happening in this country, but maybe a way to start to think about a future for energy production kind of beyond our current mode. So I'll leave it at that, and I'll take questions from there. Thanks for listening.
Thank you.
Well, it's still a mystery, but it is an interesting mystery.
It's a mystery, yes.
Yes. Okay, there's some questions here.
The pond on the left of what's pictured, is that a fishing pond, or what was that used for during the time of the solar pond?
Yeah, so we were speculating about this right before the talk. So the original Miamisburg coal power plant was here, and I think that what became the solar pond was actually the cooling pond for the power plant originally. Of course, that was gone by the time they had been gone for a while. By the time they built it.
They had coal burning from about 1900 on in Miamisburg.
Right.
If you're really old timer,
I remember the old town.
yeah, you're a really old guy. That's all we can say. Facts are facts, right? But the thing is, they also might have dug those out when they were building the New York Central Railroad through in the first part of the 1900s. They would have, they cut away the hillside, but they still had to run, build the levee all the way down across the Miami River. They would have needed gravel and so forth. So it's very likely these were areas that were dug out, and then they said, well, we got a power plant here. There's a place to dump our cooling water and all the other stuff to circulate. And so they were just there, and it was not developed. So it was available. It was land not being used, and that was part of it.
Yeah, and they actually just reshaped this pond. This was an existing pond also, but they just reshaped it into the solar pond.
Yeah. Let me make a testimony. I swam in that swimming pool in the mid-1950s, and I can assure you that's the coldest bloody water you ever. It was so cold because it came from groundwater, and it was terribly cold. I used to go in the little kiddie pool because it'd be warmer than it was in the deep pool. Now I never swam after we had the solar pond in there. I lived here, but we lived out in a house somewhere else, and it just wasn't part of our lifestyle. But yeah, I would have liked now to have known what it was like when it was warmed up. It would have been a lot better because it was so cold.
This was one of the sort of ongoing things that you read about in the newspaper articles from that time. The pool was costing the city a lot of money, right?
Yeah.
Every year the city was losing a lot of money on the sort of maintenance and upkeep of the pool. And it makes sense. It was built in 1934. It was built in a sort of different era of building pools. They had sort of jerry-rigged it to heat it. But by the late 70s, the city is kind of losing money on this pool. And it's kind of amazing that it lasted until 1995.
Yeah, every time I guess there's really no other source in the municipality of Miamisburg have swimming. And Franklin had a pool, and Dayton, and I think West Carrollton had a pool, and other places. But so in Miamisburg, I think they put something in the schools, but they weren't open to the public, right? Didn't the high school or something have a swimming pool? I didn't go to Miamisburg, or I didn't have kids in Miamisburg at that time. Anyway.
Other questions?
Yes, Joe.
78 was the year of the blizzard, which was really severe here. And that ice would have stopped a lot of the sunlight penetrating.
Yeah, I think
So
that,
that was a unique time.
yeah.
Yeah.
And I think you see that, and I wish that they had publish the information for the next winter. And I would be curious to
Yeah.
see whether it got that cold again. I know that it didn't freeze the next winter. It only froze that one winter because it was an exceptionally cold winter.
And the second thing, 82 was when Monsanto left, so Dr. Wittenberg retired from Monsanto.
Yeah,
EG&G may not have had interest in anything like that
right.
in order to cut the budgets for the bidding for DOE contracts.
I think you're right. I think that transition was not just Leighton Wittenberg retiring, but the fact that Monsanto left. Monsanto had this policy of trying to do stuff. EG&G was, I believe those that worked for EG&G would make money.
Right.
And they didn't care what they cut, as long as they could make their money. And so
Right.
I think that changed a lot of, because I worked here in '84, and I know that last couple of years was a whole lot supportive of any innovation. If you didn't bring money in, they really didn't have any use for it.
Yeah.
And I think that was, part of the situation.
Yeah, I think that, yeah, I mean, the other thing that's happening here, of course, is that in the 70s is the oil crisis. The DOE starts to push all of the labs to do renewable energy projects. So we see renewable energy projects surface at almost all of the labs around the country, national labs and subsidiary labs. And for Wittenberg, I think this is a really good chance for, as leader of the energy group here at the Mound, to say, look, we're doing this too, right? We're involved in energy production. Obviously, there's an interest from the city on doing this. By the mid-'80s, the cost of fuel oil had dropped again, right, nationally. And so in comparison, by the mid-'80s, the solar pond financially may not have looked like that good of a deal anymore, right, as the price of fuel oil dropped again. And so, a lot of things that happened in the 70s that were pretty revolutionary and cutting edge got pulled back in the 80s.
Economics changed a lot of that, right?
Economics
It
changed.
changed in the big scale, and
Yep,
But like you say, it's a storage of low-level heat,
yep,
which makes it very limited in what it can actually do.
right. You could only use it for heating, that was it. I think the other issue that it ran into, and you start to see this surface in some of the writing, is that they had trouble with the liner itself. So they were losing a lot of salt, actually. They keep adding salt to the water every year in order to keep the gradient high enough that it was storing heat, simply because the liner wasn't.
so that's like putting money in there. And the salt, of course, is going into the soil, and that's going to be an environmental issue that wasn't probably thought of in the original concept. So life gets very complicated when the whole story gets wrapped up. So I was going to ask, you said a couple examples. Are there really viable solar ponds in operation now anywhere in the world that really are?
There are. So Einbokek in the Dead Sea is still in operation it generates electricity. It's huge. They basically have fenced in an area of the Dead Sea and artificially raised the salinity gradient of it. So much cheaper to construct, at a much larger scale, in an area where the insulation is much higher.
Yeah.
Right? So
They can increase the efficiency enough, because this was kind of low-tech, i.e. low cost,
Yeah.
and that impacts efficiency.
Yeah.
And then if somebody's barely making it economically, and it changes, and it's...
Yeah, and I think the thing that I didn't really talk about, anyway, the pond itself, the construction of the pond costs $70,000, right? So I spent $70,000 on the thing. In total, in 1980, we spent another $14,000 replacing the heat exchanger. So it's not a huge, expenditure.
Not even at that
Not even at that time. Right? I mean, they spent $200,000 on the slide, just to put that in.
Yeah, and it's protected, right? And now again, you take the economics of 45 years and do it, but still, it's the operating costs that were high. You're replacing the salt, maintaining it, the corrosion issues, those are the ones that were killer, not the original
Yeah.
building.
And they didn't anticipate many of those operational
Yeah.
costs, yeah, absolutely.
They didn't study the chemistry of corrosion of highly concentrated salt on almost everything. Hardly any metal, any affordable metal that will withstand that environment.
Yeah, and that was one of their most expensive problems they ran into.
So I'm going to have one more, maybe two more. One is, Do you know anything about the data that was collected? I mean, you plotted charts. Did anybody ever find you any more data that was collected of the operating of the pond?
Not after 1983.
Okay, so none of that was, that we know of?
Yeah, no, the Mound Center didn't collect any.
No. I mean, it would have been done by individuals,
Yeah.
probably. And my other comment is, if you're not funded, you have no motivation to write a report. And if they're funding you to do another job, that's what you're going to do. And I think, Leighton didn't completely retire. He went to somewhere else and worked for something else for a couple more years. But, it was, things were cut. And it was a temporary thing. He was interested, but not, not a career like some of his other.
Yeah, and I think when, in the initial writing about it, and the initial framing of the project from Brian, it's kind of framed as this like, we're gonna put it in and it will work, and we'll skim the top of it like we do the pool, and we'll never touch it again, right? It's this sort of like framing of the thing, which is a lot of, early technology,
Sales
right?
stuff. It's sort of what you hear nowadays about all the technology. Just put it in and plug your batteries. It'll last forever and a day, and guess what?
And but to be fair, they didn't know, right?
Yeah.
This was really the first operational one of its kind.
And you made the very positive assumption.
Right.
Because you can sell that way. Realists don't get funded. I know. I understand completely. All right, any other questions? If not, we got one more.
With the solar ponds, are there issues with it attracting, like, animals that drown in it?
Yeah,
It's on
so-
the top that needs maintenance.
So one of the big operational costs, doesn't appear to have been hugely costly here in Miamisburg, at least no one was writing about it. But in the other solar pond, the one in New Mexico that been operating, is just keeping birds off of it, right? So that causes two problems, obviously falling in it and dying and dropping to the bottom, but also any kind of disturbance to the top of it actually can interrupt the storage, right? It actually reduces the storage.
Water.
Because it's water, right? So if a bird lands on it, it causes minor convection.
And they can accumulate with a bunch of birds, right? And it's multiplication.
Right, so one of the reasons, and the one that I was proposing for Copenhagen, is that we put it in a greenhouse to limit that, right?
Okay, well, thank you, Jay.
Yeah.